All right, so we're going to talk about equations of lines. Now, remember, a lot of chapter 1 I mentioned is a review, but also a lot of chapter 2 is a review. 2.3 functions should have been a review for you. Equations of lines is meant to be a review. But although it's not a learning outcome, you will see at least 2 problems on your test, okay? You'll see 2 problems where I will give you information about a line and expect you to be able to write the equation. I will also give you information about the line and expect you to be able to graph it. So technically, 3 problems from this section on your test. Next test should have about 25 questions, okay? All right. So we are going to do quite a bit in this section, but most of it is meant to be a review. We're going to look at slope-intercept form, standard form, point-slope form. We're going to look at equations of vertical and horizontal lines, parallel and perpendicular lines, and graphing linear equations. Okay? So quite a bit in this section, but this section is designed to be a review for you. Let's talk about slope-intercept form first. Now, last class, I can't remember who brought it up, but someone asked, will we be working with y is equal to mx plus b form? And my answer was yes. That is slope-intercept form of an equation. And we're going to talk about quite a few. What I would suggest is that you make a list with the different forms that we're going to discuss. Slope-intercept being your first, okay? Your second being standard form, and then point-slope form, okay? So when we talk about slope-intercept form, most students will tell me, well, y equals mx plus b comes to mind, okay? Where m is the slope of the line and b is the y-intercept, okay? So if we have y is equal to 2x plus 3, so we know that means that the slope of the line is 2 and the y-intercept is 3. Someone tell me a little bit about the slope. What do we mean by slope of the line? The rise. What else? Over run. Okay, so we have a lot of different ways that we think of slope, but keep in mind that slope, a lot of students will say rise. You guys said rise over run. Okay, maybe what's another way to describe rise? What's some words we sometimes use? Change in the y over change in the x coordinates. So sometimes you'll see change in y over change in x, or sometimes we call it delta y, which means change in, and delta x. So when we think about slope, always remember that's how your line is changing. It's how it's moving up or down, that vertical change over that horizontal, okay? And remember, when we say change in y, that's given that we have 2 points on that line, right? So we may call them x1, y1, x2, y2, okay? So keep in mind, when we talk about slope, we're talking about the change in y over the change in x, or delta y over delta x. Is there another formula for m that uses these 4 variables that you see? What's another way to write that using these variables? Do you remember? Okay, which would go in the numerator? Which should go in the numerator?
Y.
The y is the change in y, which if these are 2 points on a line, the change would be y2 minus y1. Remember that? All over delta x, x2 minus x1. So the change in the y coordinates over the change in the x coordinates, okay? So I don't want you to forget what slope means. You've talked about slope quite a bit in your previous 2 courses, but we're just going to just quickly review it, okay? So when we think of slope, and you may need to know this formula, I may give you I might give you 2 points that a line will pass through and expect you to find the slope of the line, or write the equation of the line. And finding the slope is going to be very important. So remember, don't forget your formula. y2 minus y1 over x2 minus x1. Okay? Now, when we say a slope of 2, don't forget, what does that mean? It means that if this is a line, this is a point on a line, and we think of slope as, think of m as movement. It's how we move from one point on a line to another, or it measures the steepness of a line. That's what slope does, and it kind of gives us directions. So if I tell you that a line has a slope of 2, this line has a slope of 2, that means from some point on that line, that if m is 2, that's 2 over 1. That means, and let's make my point. Give me a little more space. Let's start it here. So if I have a point on that line, and this is really in my way. Let's see, can I move this out my way? Yay. All right, and if I have this point, we're going to X that point out. We'll start here. If I have 2 in the numerator, if you remember, that means that I'm going to move up 2 units. The change in y, delta y, is 2. So because it's positive, I'm moving up. And then 1 means that I'm going to go which direction?
To the right.
To the right. Very good. 1 unit. And then I could draw my line. Okay? So remember, slope measures the steepness of a line. Okay? And it's the change in y over change in x. Let's suppose I have a slope of -1/3. And I'm starting at some point on the line. In which direction will I go?
Down.
I'm going to go down 1 unit. Very good. Because there's a negative in the numerator. So I'm going to go down 1. Positive 3 in the denominator means I go right 3. And then I would have my line. So I just want you to recall, remember, slope is very important when we begin discussing lines, okay? So, any questions about slope? All right, and I use the word y-intercept, so b is 3. And this is if our equation is of this form, y equals mx plus b. What is b? We've talked about slope. B is the y-intercept. Okay, so b is the y-intercept. Describe that to me as it relates to a graph.
It's the starting point. Well, you can start there and then use the slope to make your line.
Okay, you could. She's saying if I want to graph a line, I could start at the y-intercept and then use the slope to find another point on the line and then graph it. That is true. But what is, if I had to define, that's how we could use the y-intercept to graph. But how would I define the y-intercept? It's the place where the graph will do what? Will cross what? The x, not x, but what? The y-axis. Very good. So the y-intercept is the place where your graph will cross the y-axis. Very good. So when we have an equation in this form, y equals mx plus b, very powerful statement. It's telling you the slope and it's giving you the y-intercept, another point on that line. Okay, it's giving you a point from which you could start. So if we wanted, question? Okay. So if we want to graph this, let's just go into, so we're using slope-intercept form, discussing it, we're going to graph it. So if it's in this form, so if I want to graph y is equal to 2x plus 3. Okay, as JJ said, we use the y-intercept. We want to go through and label. We know the slope is 2, and we can write that as 2 over 1 to remind us that we do have to move 1 unit to the right. And our y-intercept is 3. So this is our y-axis. This is our x-axis. Okay? So we have our coordinate graph now with x, which is the independent, right? And y is the what? Dependent. Very good. And so we go up 1, 2, from 0. We always start at the origin. This is 0, 0. And we're going to go up 1, 2. And I'm going to do this one in red since the graph is in black. Let's see if I can get my red pen to act better today. So we go up from 0, 1, 2, 3 units. This is 3. And we have our point. That's the y-intercept. That's the place where this graph will cross the y-axis. And our slope is 2 over 1. So from this point, how many units? Remember, slope is the change in y over the change in x. Delta y over delta x. So from this point, should I go up or should I go down? I should go up because it's positive in the numerator. And it's 2, so I'm going to go up 1, 2 units. There's 2. Notice, some students will count this as 1 and then this 2. You move and count. That's 1 and this is 2 units. And then I'm going to go right 1 because delta x is 1. The change in x is 1. And all I need will be 2 points, and then I could graph my line. Okay. And we always label this as y equals mx plus b, or 2x plus 3. Now, if I asked you from yesterday's lesson, hopefully you studied, what's the domain and what's the range? What would you tell me?
The domain is negative infinity to positive infinity.
Excellent. Negative infinity to positive infinity. And what's the range? The same. Excellent. Because remember we said it's a line that has a what? Slope or a slant. So therefore it's not vertical, it's not horizontal. If it has the slope, then its domain and range will be all real numbers. Or from negative infinity to infinity, writing it in interval notation. Very good. Is this a function?
Yes.
Yes, because it,
Crosses the y-intercept.
well, not because it crosses the y-axis, but because if we draw a vertical line, it would cross only what? One time. It would pass the vertical line test if we were to draw a vertical line. Very good. Okay. Any questions about y equals mx plus b? It's my favorite form of a line because just looking at the equation, we'll know the slope and we'll know the y-intercept, and we could therefore, as we just did here, we could plot a point. I mean, we can graph the line, I'm sorry. Okay. Any questions? All right, well, let me give you this. Suppose I ask you, and I'm going to draw a line, okay? And you know quite a bit about this line already. You guys just answered quite a few questions. In other words, you told me you should know its domain, right? What's its domain and range? There you go. Very good. So you know the domain and range will be negative infinity to infinity, all real numbers. Now, suppose I asked you, using y is equal to mx plus b, to write the equation of this line that you see. How could you do that? How can you write the equation of a line? This line, y, in y equals mx plus b form, in slope-intercept form. Well, start with, what's b? What does b represent? The y-intercept. Where does this line cross the y-axis? At 3. Very good. This is 1, 2, and 3. So at least we know that b is 3, right? We know we're going to have x, and now our missing part is m. How could we find the slope? As long as I have 2 points, you should be able to find the slope. Okay, well, okay, I like that. It crosses the x-axis right here at another point. So, how do we go from one point A, and if I called this B, Joseph said it crosses at the x-axis here at 3, 0, crosses the y at 0, 3. How can I use my slope? How can I use, no, I'm sorry, what is my slope? What could I use to find it? Rise over run. So I could use the 2 points and use this formula that we just discussed if I want. Label those 2 points and use the formula. But I think an easier way would be to just see, let's see, what is the slope of this line? Well, to go from point A to B or B to A, it really doesn't matter because this is a linear function, this is a line. The slope is the same from point to point, so we don't have to worry about when you go to a different class, it'll be a little bit different when you work with nonlinear functions, but for now, we can go from B to A or A to B.
Is it 3, 3?
So it's 3, 3. Very good. Well, negative 3. Very good. Because we go down what? 3. So we go down, that makes the numerator negative. So negative 3, right? And then we turn, we went 1, 2, 3, and how many units to the right?
1, 2, 3.
1, 2, 3, and going right is positive. So my slope is therefore, what's negative 3 divided by 3? Negative 1. So this becomes negative x. So that's my equation. Remember, we always simplify those fractions. So remember, how did we get that? So does that mean I should be able to go down 1 unit and right 1? Yes. Down 1, right 1. I'm right back on that graph. Down 1, right 1. Down 1, right 1. Down 1, look at that. Down 1, right 1. So our slope is negative 1, which means drop 1 point, go right. Drop 1, go right. Okay? So I will expect you to be able to, given the equation of a line, be able to graph it, as we've done here. And also, given a line, be able to write its equation in slope-intercept form. Any questions about that? Okay. All right, let's talk, and we've done point slope. Let's talk about point slope form. All right, with point slope form, remember I said I'd like you to make one list of all of your different forms. Standard form, point slope, and slope-intercept. Now, point slope form is very useful when we're trying to write the equation of a line. Let me try to get all of this out of your way. How can I get this out of your way? So you guys can see. Well, you guys have the PowerPoint, right? So you guys can see all of it. Okay, good. All right, the line with slope, it says that for point slope is very useful when we have, just as the name suggests, the point of a line given and the slope of the line given, and we want to write the equation of the line. And notice, with y equals mx plus b, you know this is slope-intercept form. With slope-intercept form, it gives you a very special point, the y-intercept. But point slope form is for any point on that line. It does not have to be that special point, that y-intercept. Okay? So, just as the name suggests, if you have a point given to you and the slope given to you, point slope form can be used to write the equation of a line. Okay? It says the line with slope m and passing through the point x1, y1 has an equation of y minus y1 equals m times x minus x1. Let's talk about this. Y minus y1. There are a lot of x's and a couple of x's and a couple of y's. Always remember, the point that the line passes through is x1, y1. So when you are substituting into this equation, you are to substitute in your x coordinate from your point here and your y coordinate here. The ones with subscripts are your points. Does that make sense? The coordinates of your point, where m is your slope. Okay? I will expect you to know point slope form and slope-intercept form. These, you will use them not only in this course, but for your courses to come. Whether it's finite math, business calculus, pre-calculus, trig, whichever course you're going to, you're going to be expected to be able to write the equation of a line. And so these two forms you really want to commit to memory. Okay? So how could we use this? Now, always remember when you're writing the equation of a line, and that's what this section is all about, always in the back of your mind, remind yourself that I need to know, I need two things. I need to know a point on the graph of the line, a point on that line, and I need to know something about the slope. What is the slope? Does it exist? Or they might not come directly out and give you the slope. They may say, okay, write the equation of a line that passes through these 2 points. And as long as you have 2 points, you should be able to find the what? Slope. So always remember, you want to know, you want to have a point or enough information that you can figure out the point. They might tell you, okay, write the equation of the line that passes through the origin with a slope of 1/3. Well, they expect you to know that the origin, what's the coordinate for the origin? What are the coordinates of the origin? Huh? 0, 0, exactly. So they might not come directly out and give you the point, but they'll give you enough information that you should be able to write it. Okay? Let's look at some problems. We'll start off with an easier one first. If we look at this problem, it says write an equation of a line that passes through -2, 3, having slope 4. So write the equation of a line that passes through the point -2, 3 and has a slope of 4. All right. So our line will go through the point -2, 3 and will have a slope of 4. Okay? Now, first thing that we want to recognize is that they gave us a point, right? And they gave us the slope. So point slope form would be our preferred form here. Okay? We could use y equals mx plus b, and I'll show you that shortly, but let's use point slope form. So we know that if we're going to write the equation, we start with point slope form, which is y minus y1 is equal to m times x minus x1. Well, tell me, what's y1?
3.
3, all right. What is, I like that, because remember this is x1, y1. What's m?
4.
What's x1?
3.
So be careful with those double negatives, okay? So this is negative, negative. So y minus 3 equals 4 times x plus 2. Now, we can write, let's go ahead. Now, we're not going to leave it in this form. Very seldom will you be asked to leave it in point-slope form. So we're going to write this in slope-intercept form. Your final answer will most times be in one of two forms, either slope-intercept or what we're going to call standard, and we'll talk about that as well. So if I want to write this in standard form, I'm sorry, in slope-intercept form, Gita, what should be my first step? What should be my first step? I can't hear you. So what do we want to do if we're going to have to get this eventually in slope-intercept form? Very good. She said to distribute this 4, right? She said multiply 4x times 4 times x and 4 times 2. Very good. We are going to begin to simplify both sides. Okay? What's next? If we want it in what's slope-intercept form? I'm going to write it off to the side. What's slope-intercept form for our final answer? Y equals mx plus b. So that means we need to solve for, okay, so I'm going to do what next? I'm going to add 3 because I want y to be isolated. And so I need to add 3 to both sides to do that. And then 4x plus what? 11. This is the equation of the line that has a slope of 4 and passes through the point -2, 3. Okay?
So both of those would be simple, or it'd be one with the 2 stars?
No, the one with the two stars is point slope form. And when you are asked to write the equation of a line, you will more than likely be asked to write it in one of two ways. Slope-intercept form or standard. Standard we're going to talk about next. Okay? Other questions before we look at standard form? Does anybody remember what standard form is? I want to take a guess. Yeah? What's standard form? This is slope-intercept. Slope-intercept form. What is standard form? Okay, she said negative 4x plus y equals 11. Okay, now you're getting close. What is JJ attempting to do? She's attempting to put x and y on the same side. So let's talk. That leads us to standard form. Let's talk a little bit about it. For standard form, JJ is right in the sense that we do want the variables x and y to be on the same side. Okay? And so standard form of a linear equation is ax plus by is equal to c, where a, b, and c are real numbers. Okay? So if we want to write an equation, a linear equation in standard form, we want x and y to be on the same side. Okay? So this equation is not in standard form, it's in slope-intercept form. The slope is 4 and the y-intercept is 11. But if we were to write it in this standard form, we would want the x and y's to be on the same side. But we have some conditions that we place on a and b. We know a, b, and c are real numbers, but we place conditions on a and b. Can anyone remember what those conditions are? Okay, a has to be positive. So a must be positive. Very good. And a and b must be integral coefficients. That means they must be integers. They can't be fractions. Okay? So those are our conditions for standard form. So it's not enough just to have x and y on the same side. You must look at the coefficients of x and y. The lead coefficient which is A, must be positive, and A and B must be integral coefficients, integers, numbers like 5, 6, 7, or -6, -7 for B. A just can't be positive. I mean, A must be positive. So keep in mind they cannot be fractions. So in the last example, our answer was y equals 4x plus 11. That was our acceptable answer in slope-intercept form. All right? So what if we are asked to write this in standard form? How would we do that? How would we do that? Remember, here's standard form. AX plus BY equals C, where A must be positive and A and B both must be integral coefficients.
Can the integral coefficient be 1?
1 is the integral coefficient. Integral coefficient just means an integer. Integers are numbers like 1, 2, 3, and they're opposites. -1, -2, -3.
So would it be
So what?
4x plus -1y equals 11? Or no?
So what should I do first? Because I will need to begin to move either Y or X.
I moved the y.
Well, let's move X. We could move Y, but we could also move X.
But it has to be positive.
Then we make it positive. So this will be -4x plus y equals 11. And now all I need to do is multiply or divide the entire equation by -1. That's going to make that negative positive. So it becomes 4x minus y equals -11. This is standard form of that same line. So if you need to, we could move y over to the other side, but then we'd have to move 11 to the left. Either way, or you could just move x and then divide by -1. So even if it becomes negative, you always can get rid of that negative by dividing by -1. Okay? So now A is 4. It's a positive integer. And y, its coefficient is -1. It is an integer as well. Okay? So these two equations represent the same line, just different forms. Okay? Questions? Joseph?
Whenever you do that, say you do that -4 over, it becomes negative.
Mm-hmm.
You move the y over, how come it just doesn't become negative to start off?
Oh, because when we move this, the y stayed on that side. It didn't move, so that's why it stayed positive. What I moved is just the 4x to the left, and I left y on the left, which it was already positive. So it stayed positive. Mhm. Now, had I moved y to the right, it would have become 4x plus 11 minus y equals 0. Yeah. Right. So standard form, I will expect you to be able to answer some questions, or be able to, I should say, write equations. So here comes the textbook problem. So in your textbook, I asked you guys to pull up your textbook on my math lab, and I have my textbook here. And we're going to look at one of these on page 234. Okay? And I want to just look at one, and then we'll move on for time's sake. And we'll look at let's look at example 4. Example 4, okay? In example 4, it says find an equation of the line that passes through the point 1, 1 and 2, 4, okay? Then graph the line using the slope-intercept form. So we're going to write this in slope-intercept form. All right, so this is on page 234 in your textbook, okay? It says, find an equation of the line that passes through these 2 points, then graph the line. Okay, so if we look at this one, what are the 2 things that I said you need to know in order to write the equation? I need to know the slope, and not necessarily B, but any what? Point. If you know B, that's great. If you know the y-intercept, that's even better. But in this case, we weren't given the y-intercept. Because anytime we're given a y-intercept, always remember, the y-intercept, in finding the y-intercept, we always let x be 0. So the x-coordinate here is 1 and the x-coordinate here is 2. It's not 0. So we know neither one of these is the y-intercept. So when you think of point slope, I said you always need a point, any point on the line, and what? The slope. So let's check off. Let's see, we need to know the slope, and we need to know a point. Well, let's see what we have so far. Do we have at least a point? Yes, we actually have 2. So that's even better. So we'll check. But what is it that we don't have just yet? The slope. So we have to find it. And they gave us enough information that we could determine the slope, right? Because they gave us 2 points on the line. What's one way that I could determine the slope here?
Y equals mx plus b.
Okay, y equals mx plus b is our slope-intercept form, but you must already know m, and we don't. How can I find m if I'm given 2 points?
Slope formula.
Very good. Say it louder. M equals,
Y 2 minus Y.
there we go. Very good. Very good. He's going back. He took us back to that formula. The change in the y coordinates over the change in the x coordinates. Or y2 minus y1 is equal to x2 minus x1. Well, and we can label this if we need to. If this is my first point, it's x1, y1. And I can call this my second point, x2, y2. Okay? So now I know that my slope will be the change in the y's, y2, which is 4, minus y1, which is 1, over x2 minus x1. And therefore, given as 4 minus 1 is 3, 2 minus 1 is 1, our slope is 3.
What's that formula called?
This is our formula for finding the slope of a line given 2 points. Now I could use point slope form, right? Or I could even use, as Ashley mentioned earlier, y equals mx plus b. Do you want me to show you how you can solve? We've done one using point slope. Let's see how we could use slope-intercept form here. And it's up to you which one you want to use, but I still want you to know both formulas, okay? So I'll show you. How can I solve this if I want to use slope-intercept form? Okay? So I know that slope-intercept form is y equals mx plus b. Well, you may be saying, but I don't know the y-intercept. That's okay. I'm going to use one of the points. I'll use the point 1, 1, and I do know that the slope is 3. We just found that. If I want to use slope-intercept form, then my x and my y's are given to me in the point. So y is 1, m is 3, x is 1, and we have to find b. Do you see what I did? If I want to use slope-intercept form, as long as I have any point and I know the slope, I can find the y-intercept. So 1 equals 3 plus b. How do I solve that for b?
You need to put b 3 on the other side.
There you go. Subtract 3. Very good. So b is equal to negative 2. So now I have all of the pieces of my puzzle. If I know that y is equal to mx plus b, I know that m is 3 and b is now negative 2, which I would prefer to write this as 3x minus 2. That is the equation of the line that passes through the 2 points 1, 1 and 2, 4.
So you could have chose either of those sets, right?
Either one. Exactly. Very good. The question is, could I have used 2, 4? I could have. Any point. Okay? So if you want later, go back and look at 2, 4. Use 2, 4, the point 2, comma 4, and m equals 3. We'll still get b to be negative 2. And our equation will still be y equals 3x minus 2. Questions? Any questions? No? All right. Is this coming back to you? Maybe? A little bit? No? Yes, no, maybe? All right. Let's talk vertical lines. Let's review vertical and horizontal lines. So when you are asked to graph a vertical line or horizontal line, always remember that an equation of a vertical line that passes through a point AB is always x equals A. Okay, let's think about this. So if I gave you a point and I tell you that it's a vertical line and it passes through the point 2, 2. Okay, with vertical lines, they're always of the form x equals some number. And the number is the x coordinate of the point. So if they say that it's a vertical line, it's going to be x equals the x coordinate. So the vertical line that passes through this point, 2, 2, would be x equals 2. Vertical lines will only have the variable x. If you notice, they don't have an x and a y. If the line has a slope, it will have an x and a y. If the line is vertical, it will only have which variable? X. So that means if it's horizontal, it will only have y. Horizontal and vertical lines only have one variable. If it is vertical, it is x equals. So this is how I would graph the vertical line that passes through the point 2, 2. Okay? What would be its domain? You know it's coming. What's its domain? And then what's its range? Thank you. What's its domain? Hmm? Well, 2 is correct. Every x coordinate of this, so like if I labeled this, this would be 2 what? 1. This point would be 2, 2. What's this point? 2, negative 1. So every x coordinate on that line is what? 2. So it only has 1. But the range, Joseph, was that second part you said. What's the range going to be? The range is going to be negative infinity to infinity. Negative infinity to infinity. So remember, if you see x equals a number, what kind of line is that? Vertical. So x equals 10, x equals negative 1/2. To graph these lines, we draw a vertical line that crosses the x-axis at this point, at that number. So x equals negative 1/2. I would go over to negative 1/2 for x, which is about right there, and I would draw a vertical line right through it. That is x equals negative 1/2. This one is x equals 2. Okay? Horizontal lines will always have only y. So if we have y equals a number, then that's a horizontal line. Think of it as it's crossing. Horizontal line is going to cross through the what? Y-axis. So y equals 3. I would go to 3 on the y-axis now. And as I've already done here, but just to show you a little more, I would draw a horizontal line, and I could label it. So when you only see y to the first, and it's y to the first equals, it's just y. I'm not squaring y, or it's just y equals a number, that is a horizontal line. Now, talk to me a bit about the x-axis. Is the x-axis a horizontal line? Yeah, she said technically, yes it is. And so it crosses the y-axis at what number? At 0. So the equation of the x-axis is y equals 0. Okay. What would the equation of the y-axis be then? Because that's a vertical line that passes the x-axis at 0. Very good. X equals 0. That's the equation of the y-axis. Okay. Let's talk slope. So, you understand that vertical lines have So, go back?
What would be the range of that?
Okay, good question. All right, so he said go back, let's look at it. What would be our domain and range? Very good, I forgot that. Let's talk domain and let's talk range. What's the domain here for the horizontal line? Excellent, negative infinity to infinity. What's the only y value? What's the range? Every single y value will be equal to what?
3.
3. So our range would be 3. Excellent. You see that? Because when you look at a horizontal line, that means there's no change in there. We have absolutely all of our y values will be what? 3. Okay? And there's no change in x. We're not rising, we're not falling, we're not going up or down, we're constant. Okay? So let's talk slope. Any other questions? All right, good question. Let's talk slope with horizontal lines. So, with horizontal lines, reuse this page. All right, so if I ask you to draw the line x is equal to 3, and here I ask you to draw y is equal to 1. What kind of line is x equals 3? It's a vertical line that crosses the x-axis at 3, so I'm going to go over to 3. 1, 2, 3, and I'm going to draw a vertical line right through 3. Now, let's use this to demonstrate. This is x equals 3. Now, vertical lines. Let's talk about slope now. With vertical lines, obviously, remember slope is the change in y over the change in x. So, when we look at this, we are changing. I can go from this point to this point to this point. So I do have a change in y, but I have no change in what? X. I'm rising and falling, but no run. So therefore, if I want to go from this point to this point, I'm going to have to go up 1, 2 units, up 2, but I'm not going left or right, 0. And what happens when 0 is in the denominator? Very good, undefined. So vertical lines have undefined slopes. Or you could say no slope. That is not the same as 0. They have undefined slopes or no slope. Write that down. So vertical lines have undefined slopes. What should be a 3?
2.
Oh no, I just went from this point to B right here. But it could be a 3. If I wanted to go up to this point C, then I could change it to 3, but I'm still going to have what? 0. Very good. So as long as 0 is in that denominator, I know it's what? Undefined. So we'll say that vertical lines have no slope. Are they functions? Would that pass the vertical line test? Very good, no. So therefore, vertical lines, think of what you know now about vertical lines. Vertical lines have, we can write it down. Vertical lines, very good. They're of the form x equals some number, right? They have no slope, or you could say undefined, just do not say 0. And they are not what? Functions. That's what you know about vertical lines. Let's talk horizontal lines. What's their form? They're going to be of the form y equals some number. Place where that graph is going to cross that y-axis. This some number is the place where the graph crosses the x-axis, okay? But if it's of this form, let's look at y equals 1. So I would go to 1, graph my line. Y equals, this is my horizontal line. Now, with horizontal lines, let's talk slope. Is there a change in y here? Are we moving up or down? No. Very good. So then 0 over, and then we could say if we're moving from this point to this one, you guys could tell me I'm moving 3. But the key is anytime I have 0 in the numerator and another number in the denominator, that's 0. So horizontal lines have slopes that are what? 0. So vertical lines have undefined slopes and horizontal lines have slopes that are 0. And you kind of hopefully now understand why. So the slope of a horizontal line is 0. Are horizontal lines functions? Yes, very good. Because they will pass the vertical line test. They're constant functions, meaning as we go from left to right, as our x's are increasing, as we look at this graph from left to right, the y's are neither increasing nor decreasing. Remember, we said it's constant. We talked a little bit about that last time. So these are facts that you want to know about your vertical and your horizontal lines. Okay? So horizontal lines are x equals some number. I'm calling it some number, but it's going to be the number or the place where your graph will cross the x-axis. And this some number is the place where your graph will cross the y-axis. But the key is vertical lines have no y and horizontal lines have no x. Is that right? Kind of a way to kind of remember those. I will expect you to know that. All right, let's talk perpendicular and parallel, and then we'll finish up with this section and move on to the next. So, parallel and perpendicular lines. Again, what are parallel lines? She's saying up and down.
They go the same way.
And they never meet. Very good. They never intersect. So, these are parallel lines. Okay? And maybe like this, you know, I'm not the best at drawing lines. There we go. These are parallel lines. Now, notice I said non-vertical parallel lines have the same slope. Why do I have to say non-vertical? Because vertical lines, these are parallel. They never intersect. But why can I not say just parallel lines have the same slopes? Very good, because vertical lines don't have slopes. He said that the slopes are undefined. So that's why we say all parallel lines except those that are vertical, because they have no slope, very good, are have the same slope. So if the slope of this line is 1/3, the slope of this line is 1/3. That's the beauty of parallel lines. They have the same slope. So if in this section on your homework, if they're speaking to you about two lines being parallel, that's their way of telling you these two lines have what? The same slope. Perpendicular lines that are not vertical, again, have slopes that are negative reciprocals. What are perpendicular lines? They intersect, but tell me a little bit about that intersection, that angle. They intersect and form a right angle. Very good. 90-degree angle. So, there's my 90-degree angle. We're going to pretend it is. So these two lines would be what? Perpendicular. So if this line has a slope of, let's just say 1/4, and this line I know is perpendicular because they intersect at a right and form a right angle, then this slope would be its negative, which means change the sign. What is the reciprocal of 1/4? Very good, 4/1. So if this slope is 1/4, this one is -4. So perpendicular lines that are not vertical have slopes that are negative reciprocals. Okay? What does negative reciprocals mean? Some might say opposite reciprocals. It means change the sign. They have to have different signs and then take the reciprocal. It means this numerator becomes a denominator and this denominator becomes a numerator. That's our reciprocal. The product of these two slopes should be -1. So if I were to multiply these, I should always get -1. So remember, the signs must be opposites. Okay, and this is all in your textbook. All right, let's look at one more and then we'll move forward. Let's see, now how would I use this? You're going to see a lot of problems like this for homework, and you will even see one like this for sure on the test. It says, find the equation in slope-intercept form of the line that passes through the point 2,4 and satisfy the given conditions. Parallel to this line, perpendicular to that same line. Okay, so basically we have how many lines here? 2. And we know for these, they're what? Parallel. So the line that we're looking for, the line that we're attempting to write the equation of in slope-intercept form is parallel to this one. Okay, that's what we're going to look at first, just the parallel side first. So if it's parallel, now stop for a second. We're trying to write the equation of a line, and what two things do we need? Slope and a point. So what have they given us directly?
The point.
The point. So always remember, we're writing equations of lines, point and slope, or enough information. They might tell us it's a vertical line. They're indirectly telling us there is no slope, right? They might tell us it's horizontal, then they're telling us the slope is m equals 0. So keep in mind, we want a point and we want a slope. All right, you told me that they gave us the 0.24, but they did not give us the slope. This is what we must find before we can begin to write the equation of the line that is parallel. We're just doing parallel first. Is that right?
Yeah.
So, what could we do to find the slope? They did give us enough information so that we can figure it out. What should we do? What do we know? Someone? We know that it says our line is parallel to this one. So if we can find the slope of this line, how should it compare to this one? If they're parallel lines. Same slope. Very good. So they gave us this line so that we can find the slope. So first thing that we need to do is find the slope of 3x plus 4y equals 12. This is not our line. I want you to see we're working with two separate lines. The line that we're writing the equation of and this line. But they give us a very important key piece of information. They tell us that these two lines are parallel. That's very important. So how could I find the slope of this line?
Subtract 3x from both sides and divide by 4.
She told me to subtract 3x from both sides and divide by 4, which is correct. She's basically telling me, JJ's telling me to do what? Put it in slope-intercept form. Because once it's in the form y equals mx plus b, we know the coefficient of x is the slope. So JJ said subtract 3x, so that's what I'm going to do. And she said 4y is equal to negative 3x plus 12. And she said that dividing both sides by 4 every term gives me y equals negative 3/4 x plus 12 divided by 4, which is 3. And this is m. So now that piece of the puzzle that was missing, we now know, because it says that these two lines are parallel. So I know the slope. We now know the slope of our line to be negative 3/4. Now, let's take a moment. For this line, it says perpendicular. So for the perpendicular line, we would use the same point. But what slope would we use here? If they're perpendicular,
They have to cross.
it would be positive 4/3. Do you see? So to write the equation of this line, this is what I need that is parallel. The second part, write the equation of the line perpendicular, that our line is perpendicular to this, we need these points. It's the same equation, 3x plus 4y. So to write the equation of the line parallel, we use this. Perpendicular, we use this. Because remember, perpendicular lines have slopes that are opposite. This negative, this is positive. Reciprocals. This is 3/4, this should be 4/3. So at home, you're going to do this part, but I want you to see why you're using 4/3. Because this line is perpendicular.
Where is the point supposed to be?
2, 4. It's right here. So let's finish the parallel line. We're finishing the parallel. I'm just going to write parallel so that you don't think it's the perpendicular. Let's finish this. So we're finishing this one. So if we use point slope, y minus y1 equals m times x minus x1, what do we get here? What's y1? 4. What's m?
-3/4.
Very, very good. -3/4. We're not doing perpendicular. I'm just showing you that so you could do that one at home. And then x minus, what's x1?
2.
2. Excellent. And then we solve this equation.
To put in
For y.
standard, right?
We're going to put it in slope-intercept. Or if they don't specify, you can choose.
Okay.
So let's go through and distribute the 3/4. And then we have plus, because negative times a negative is positive, 6/4. And then we can add 4 to both sides. So y equals -3/4 x plus. And so now we have to add 6/4 and 4. You can do that in many ways. And remember, you can reduce 6/4. 6/4 can be reduced to, let's see, 3 over 2. And so you could add 3 over 2 plus 4 any way that you want to add them. That's okay. I don't have a lot of room. I would add them on the board. You want to do it on the board? Let's look at it. 6/4 plus 4.
Don't you have to make the bottom the same?
So 6/4 plus 4 over 1. Common denominator is 4. This stays 6. What do I need to multiply this one by?
4.
Over. And 16 plus 6? 16 plus 6?
22.
And we reduce that to what?
11/2.
There we go. Very good. 11/2. So we did that one on the board, plus 11/2. And that is our equation in slope-intercept form. Okay? So 6/4 plus 4 gave us 11/2. So this line would cross the y-axis at 11/2, and it has a slope of -3/4. Any questions? I'm going to let you do the perpendicular. Try it at home. And your answer is on the next slide. Any questions? Anybody still copying? You got it, Laura? All right. Did everybody get it? Okay. All right. So we will stop here. We're not going to do any modeling, and we're going to stop here. So what I want you to do is pull up your slides. Let's look at section 2.6 now, okay?